This video will introduce Pandas data frames. Now I'm assuming that you're all ready to go with Jupyter Notebooks and the Pandas library, probably by installing the Anaconda distribution. But if not, go and take care of that now. I'm going to be working with my notebook in Visual Studio Code, but you can also do this in the Jupyter Notebooks app or Jupyter Lab, or I guess any other application that handles Jupyter Notebooks. So to organize our data and to help us manage that data and interact with it, we're going to use a data type that's called a data frame, and it's part of the Pandas library. It's a structure that we generally visualize as having rows and columns. If you're familiar with the idea of a 2D array or matrix, it's a lot like that. A good analogy for a data frame is a table, as you might find in a spreadsheet. So you can see an example here. We have 3 columns, course, instructor, and enrollment, and then we have 6 rows, and all of this in the middle represents the data itself. Putting our data into a data frame gives us a variety of ways we can search that data, filter it, aggregate it, and it's also useful when we want to visualize our data with some different kinds of graphs or charts or plots or whatever. Often we're going to create our data frame and fill it with data from an external source. We might pull from a database or a web-based API, for example. We're going to learn how to read data from a file and store it in a data frame in a separate video. But first, let's see how we can create a data frame ourselves. All right, I'll add a little code cell here so we can start working in Python. And the first thing we're going to need to do is to import that Pandas library. And by convention, most people then alias that to PD, just to make it a little bit shorter. Most of you, or many of you, are probably still new to Jupyter Notebooks. So just a couple reminders here. I'm going to run this here to get it up and running. If you haven't done so yet, you may be prompted to select a kernel. You're going to probably want to use the Anaconda kernel, or the one that installed with Anaconda. It'll be called Base Conda, I believe. And other than that, it looks like we are off and running here. So I'll keep that in a separate cell just for the sake of visual clarity here. And let's go ahead and get started on making our first data frame. The simplest way to create a data frame is to just base one on a list, the good old-fashioned list data type that we're used to from our experience in Python. So I will make a quick little list here with just some automobile manufacturers in it. Nothing special about that. That should be familiar to you from your previous Python experience. Where it's going to change is that we're going to use in the Pandas class, the Pandas library, there is a class called DataFrame. And what we want to create is a DataFrame object. Now the constructor for a DataFrame object will take a list as an argument and make that list data into a DataFrame for us. So by convention, again, we tend to call this object df for DataFrame. If I'm going to have multiples of that, I might call it df1, df2, and so on. But df equals PD for pandas, data frame, and then the parameter is, there are a bunch of parameters, but what I want to mainly pass in is the data we're going to use, and so that is car data. And then in order to render this on the screen, I just need to reference that so that it gets displayed in our output. And there we go. It is not a very impressive data frame, but it is a data frame. I can see the 3 pieces of data that I added to it. There's one column, and it displays those as 3 different rows when we send it in as a list. I will point out that the shorter syntax for this is I could take this list definition here and just put that directly into my constructor call there, and then I don't need that first line of code. And that, I think, is probably a more Pythonic way of doing it, and for a lot of you that will be the way that makes more sense to you, or the way that you feel it should be done. I'm actually going to stick with my old syntax, just because I want to make it clear to people who are still fairly new at all this that we are talking about a list. Okay, so let me just make sure I haven't messed anything up. Good. The data frame constructor, incidentally, can take a lot of different arguments. It's a very flexible class. It can do all kinds of different things, and it can work with data in all kinds of different formats. So a good habit to get in right away is to use a keyword here to identify which argument we are passing in. So I'm going to say data equals car data, and I'll try and remember to do that each time. So that you can get in the habit also. In Python, for those of you who don't know or don't remember, if you start passing in arguments, they have to be in the correct order. If you want to go in a different order, or if you want to not worry about the order, which is, for me, I don't know what the order is for all those things, then you can just use a keyword to identify which one you are passing in. So that should get us going with that. Now, as I said, that's not the most exciting data frame in the world, but in addition to taking a list, we can also, which is going to create a single column data frame, we can also use that constructor to create a data frame with multiple columns. And to do that, we are going to actually use a dictionary with lists as the values. And so in order to save the typing here, I have kind of pre-typed it. So the syntax here, when you create a dictionary, remember we're talking about a key value pair. The key is how we find it, and the value is what is associated with that key. And the only thing that's possibly different than what you might have done in the past is, instead of having a single piece of data there, I'm going to have a list. So next to SUV, I have Explorer, Blazer, and RAV4. The next item in my dictionary has the key truck, and it has F-150, Silverado, and Tacoma, and then another one for car. And again, we will render this on this. Oh, I've only made a dictionary at this point. I guess if we want to see what that looks like in Python, we can just reference that here and call it. And so there's our dictionary. Again, this is nothing specific to data analysis or to pandas. This is just good old-fashioned Python. But what we want to do now is pass that dictionary into our data frame constructor so that we get a data frame with rows and columns. And so I'm going to say df equals data frame, data equals car data. And then we'll render that and see how we look. And I've got an error. Oh, I forgot to reference the pandas library. As I often say, I don't bother to go back and edit out my mistakes because it's fine to see that teachers make mistakes too, and I probably make more mistakes than most. So, all right, now we're looking good. We've got probably a little more what we would expect to see with the data frame. I've got a setup of rows and columns, and what it has done is it has taken those keys in what was my dictionary, and it's made those into column headings. All right, and for the row headings, since I didn't provide them and we haven't looked at how to do that yet, it's just by default it's going to number those, and as is usually the case in computer science, it's going to start counting at 0. So we have 0, 1, 2 for our 3 rows. If we want to reference a single row out of that data frame, we can do that by calling the name of the data frame, and then with our index here, I can just put one of the keys there, and I'll run that. And what it has done now is it has used my string SUV to go into that data frame and retrieve the data that's associated with that. I think I said row just a moment ago, but we're retrieving a column here, right? So we have Explorer, Blazer, and RAV4. At this point, it's maybe worth pointing out that we're not actually dealing with a key and a list anymore. We're not dealing with a dictionary. We're dealing with a data frame. And so SUV isn't part of a key value pair. It's a column in our data frame. And we can confirm that by checking the type here. I'll say type df SUV. Oops, some extra symbols in there. And run that. And it's identifying the data type for this structure as a series. Okay. Now, a series is a little bit beyond the scope of our video here. There's all kinds of stuff that you can do with a series, and you can look into that on your own. But for now, I just want to point out that a data frame, we can now start to think of it as a collection of series objects. And so we can break those, we can pull those series objects out individually and work with them by themselves. Now, a data frame does allow us to have it does give us another way to access a series from within there. So let me get rid of that little type check there. So in addition to this bracket notation where we're going to reference an element, I can also just use dot notation, and I can say .suv, df.suv, and that's going to do the exact same thing. Programmers being programmers, as I mentioned before, we often like to keep our typing as simple as possible. So many programmers will kind of gravitate to this notation rather than using the brackets. I'm going to make it a point to at least try and remember to use the brackets, partly to remind us that we are not just accessing kind of a normal variable or property within that object, but we are dealing with a data frame and with a series here. And there are also some situations where you can't use the dot notation. For example, if you have a heading that's got a space in it, if we wrote out sport utility vehicle with spaces in there, then I couldn't put sport utility vehicle with those spaces. Spaces would be considered new identifiers, right? And then also sometimes there are some reserved words or some properties and functions inside the data frame class that we don't want to duplicate. It would cause identifier confusion. So I'm going to stick with the convention of referencing indexes with that square bracket notation. So that gives us one column. What happens if we want to get a second column or multiple columns? So we can do that. There's a notation or a syntax for that. So I can call that data frame again, and when I go to identify my element, my index, I'm going to nest inside of that another list. So we have this sort of nested bracket syntax, and now I'm going to just identify within that the different headings I want, the different columns that I want. So I'm going to get car and SUV. And let's just run that and see what we get. So what I've done now, and it's confusing, it's probably worse on this little video screen to be able to see that. Let me see if I can zoom that in a little bit. Visual Studio is helping a little bit with the color coding, but instead of having just the single brackets like I have here in the yellow, I'm going to have those brackets, and then inside of that I have another set of brackets, and I'm just going to have a list with all of the columns that I want to retrieve. I only gave myself 3 columns to work with, so there's not a whole lot to do here. But a couple things that are noteworthy. One is that I can pull them out of the data frame in any order I want. So our original data went SUV, truck, car, and here I've pulled out car and then SUV, and we've retrieved them now in that new order. It's actually returning a data frame here, right? You can tell by the way it's rendered that it looks just like our original data frame. So we've pulled out a subset and we've made a new data frame. And if I just want to work with it here, that's fine. But it's maybe worth noting that maybe I would like to save that or reuse it, or maybe maybe I'm going to pull out a subset of data and do a bunch of stuff with it. Then I can save that to a new data frame. df2 is not the best name for that, but I might call it something like subset or car SUV or something like that, and I would know that that's my data set with all the cars and SUVs from my data set there. Okay. Retrieving a row instead of a column is going to work a little bit differently. So let's take a look at our original data frame here that we're really going to be using. So if we want to get one row out of this, we don't have these named indexes to refer to. The DataFrame class gives us a couple of indexable attributes that we can use to retrieve a row. One of them is by its numeric index, and that's the iloc attribute. And so what that does is if I say df iloc, and if I want row 1, I can put 1 there. The I stands for integer because we're giving it the integer index of the row that we want, and that should give me Blazer Silverado Corvette. Okay, Blazer Silverado Corvette. You can see it's rendered vertically here because it's only one little piece of data there. And if we want to get multiple rows, we have the same option of nesting inside of this another set of square brackets and kind of listing the rows that we want. So let's say I want 2 and 1. That should give me the RAV4 row and the Blazer row. You can see that now this gets rendered as to look similar to a data frame, and that's because the iloc attribute, when we call it with a list like this, is actually returning to us a data frame. And so just like up above when we called out multiple columns, it gave us a data frame. So same idea here. The other attribute besides this iloc or iloc, I don't know how you're supposed to pronounce that. I say loc because it's like location. The other attribute we have is just loc without the I. And the idea with the difference between the two is that loc is going to take an index by name rather than the integer number. So if we say, for example, to do this, I think I'm going to copy and paste our original code for defining our data frame just so we have it here. I'm just making new cells, obviously, and this is just kind of a scratchpad workbook for me. So this is just so we have it visually on the screen closer to where we are doing our work. That's what we got. So if we want to retrieve using the loc attribute, I'm going to say df.loc, and now we're going to refer to the names of the rows by these indexes over here. Well, I didn't define any, so by default, the DataFrame class has just given them those numeric, those same integer index numbers. So if I run that, if I put df.loc2, it works exactly the same. You probably at this point, I hope, are asking, well, what's the point of that? We didn't, that didn't really help us solve anything, right? In order to make that more useful, we are going to need to define some index names for this data frame. And we can do that. I'm just backing up here again to our constructor call. So I said that the data is the car data, and that's the dictionary that I passed in. Well, I can add on as another argument here a list of indexes. I should be, I think, saying indices. I think that's the proper plural for index, but I just can't go there. So I'm going to say index equals, and now I'm going to list what I call each of these. And so my little simple data frame here, row 1 is my Ford vehicles. So I'm going to call that Ford. Row 2 is Chevy, and row 3 is Toyota. And I'll execute that again, and you can see it's updated it now, and instead of having those numbered index values over here on the left, now I've got the names that I have assigned. And so this code shouldn't work anymore, I don't think, because loc is no longer a named index, but I can instead call Ford, for example. And now it's going to retrieve everything that is in my Ford row, which is an Explorer, an F-150, and a Mustang. Hopefully that helps understand what's the point of having an iLoc and a loc, is because we eventually we probably want to name our indexes, and that makes it easier to remember what we're referring to. It makes your code a lot more readable, that kind of thing. And once again, we have that same syntax. If we want to retrieve multiple rows using the loc attribute, I can say, well, give me Chevy, if I spell it correctly, and Ford. And oops, I've neglected to put in my inner brackets there, which is an easy mistake to do. But remember that we need to have the outside brackets, and then in the inner brackets, we're defining a list of our rows that we want. So now it's giving me the 2 rows for Chevy and Ford. And again, it's returning a data set. So maybe I want to save that. Maybe this is my little subset of domestic vehicles. And so I can say domestic equals that data set. And now I have that domestic data frame in addition to my original data frame, so that I can do, if I just want to pull data on the domestic manufacturers. Now, as is so often the case, data frames are such a big topic, and there's so much you can do with them. They're very powerful. They're very flexible. They do a lot to make it easy for us to manipulate data and to work with data. So it's worth exploring on your own if you're really going to be doing some data analytics. Our point right now is just to give us a basic understanding of what a data frame is, what's the vocabulary associated with the data frame, how do we create one, and how do we access columns and rows within that data. And so this is a good place for us to stop. The next video, we're going to move on to importing some data from a file and putting that into a data frame, instead of having to type all of these elements in ourselves. Before you get to that, I would really encourage you to just sit down with an empty notebook here and try creating a couple of data frames and get the hang of the syntax. Try pulling out different rows and columns and identifying indexes and things like that, because you really do need to have a grasp of how this all works so that you can work with these data structures in the future. As is always the case, if you have any questions about data frames or anything I did in this video, please reach out.